Can you hear me well? Yes. Done. Cool. Part 5. We're doing the learning piece in stream, so we're using open lesson. We have a bit of a format to them, testing a different stream format where you can see here on my stream that I have above me an actual open lesson window, and so that's going to be open lesson while learning PCB design. We're putting this to the test. Let me just post the and put it in community as well. Here I'm let's fucking go. Okay. Cool. So what are we doing today? We're doing the PCB design thing, but and we're doing it in a you can see the screen is a little different today. I actually kind of have I kind of have the main display here, and then I have a secondary screen where I have also the questions, but now I have these. Hopefully you can see. This is actually going to be don't want this to. Oh, that's like probably we will be just playing with this second. I'll have it like. All right. Yeah, that sounds good. So on one side we have here. You're not seeing what I'm doing, but I'm just that we have some. I'm just renaming things in OBS. I know where to find them, and just gonna have to set up so that I can see here and you see what I'm seeing. So I have two monitors, and I'm essentially having on one side open lesson here so that I can look at the probes, right? So I can, so I'm gonna go back to and PCB design. Go to the and we're doing the hands-on project exactly. So we had done the software review, we had done the layout routing techniques. We didn't finish them, but it's fine. We're now doing the hands-on project. That's feel like probably we'll skip manufacturing and testing for now, and then circuit schematic capture, electronic. We'll see that we're doing something simple. So we're just doing these three probably hands-on project this thing. So let me just go back session. We're doing it in English, and so now you can see both things. So you can see here that I have these, and I also have then open lesson here that is getting ready. So you're going to be able to see what I do with open lesson and at the same time what I'm doing here. And I just wanted to open. There's PikiCat SHP, then there's schema SCH. So what we were doing is we were building exactly. So we were past these, and then we were doing schedule symbol schematic diagram of an LED circuit, including a resistor and a power source. That's what we're doing. And so let's get started. So we're starting with a session, and I'm not going to use any of the tools here for now, although I might kind of go and draw something. But the task at hand is, how is the resistor connected relative to the anode in your and I'm gonna be no, I will actually use these. So what is the anode? I'm that done with this stuff, right? So we'll just and we'll open the schematic. we had this thing here. So we had this very ugly. So this is supposed to be the LED. I don't know. I'm remembering this. That's supposed to be the resistance. Is it schematic hierarchy? That's uh, okay. So there's oh, and by the way, what I'm gonna do is Frog is having this one is part like an LED diode. You know, polarity. This is positive side. Okay, so that's the positive and negative side kind of thing. Okay, that's all good. So I guess in numbers 1, 2, anode. Okay, so AK is probably anode, cathode, pin names, right? That's probably anode is probably this one. And so essentially, what do I need to do? Why do I have here schematic hierarchy and I don't have stuff in here? All these, just a schema. So this is just a schema. Oh yes, I wanted to actually so that I'm sent to the LLM tutor. So we're seeing now basically. Yeah, I wonder. Like, I don't want this to like my face probably already bothers enough, but it's if, like this is probably too small. You're not gonna see. Uh, we'll see. Um, um, fine. So how is the resistor relative to the anode? Where does the resistor go? Does it really matter if it's just like a closed circuit, right? If it's going to be something closed, right? Or is it going to once I go to the ground? I'm so bad at these, but okay. So we have. How do I even know that this is a resistor? That is the thing, right? Do I even know that? Yeah, library description resistor, LED device, power. The power is 15 volts. First, what does the diagram say? Does the diagram suggest anything? Positive, positive. They're like a short codes. Like I want to know how I can rotate. Rotates R. Yeah, okay. Got this stuff. I can edit stuff. So I guess I need the resistance. It didn't actually rotate the cable. Okay, M is to move. It's very similar to very similar to how like either and so we have something like this. We now or should we should just rotate This is interesting because you can rotate actually, and it rotates really it actually does rotate the element alone, and I mean I think that's actually um. But why am I not seeing here how I want to do something like, and how do I know the value of the? How do I know? I'll just open graph point. How do I know? I'm what I'm realizing a lot as I'm realizing is the teaching kind of like I'm gonna still, but I'm kind of like some people use different tools, they like different. Then why do why do we? I almost feel like this entire panel is canvas is used to draw stuff, a book, but I think that might actually go. Although no, maybe no, because maybe someone just doesn't have grok or doesn't have anything else, so it's fine. Let's just go. So we're doing these. Okay, so grok. Um, I'm testing KiCad. Building a schematic for a simple one LED circuit. What else am I missing? How do I know the value of the resistor? Like, let's need like 4 volts or something, right? How the physical layout on a board might be. That's a good question. So, but let's see what grok says first. So, our resistor LED ground or return to almost correct for a simple light. It's a classic series. Here's what you can see: the KiCad real life for beginner friendly, safe 1 LED per circuit. The most important piece. Current limiting resistor, you already have it drawn, but you need to pick a real value. LEDs are current driven devices. They have almost no resistance of their own, so without resistor, they act like a near short circuit and burn. So the voltage is 15 LED for voltage, depending on color. Red, orange, yellow. The two. Do I know what color this is? The other thing's missing in a proper schematic. The ground symbol. So we're missing the ground symbol. Okay, so how do rock KiCad shortcut quad. And like these buttons, bro. Like you're not gonna just add. Okay, that opens the library, and and we want, so that's a schematic, and we want ground. Our okay, that's ground, and yes, we do just, so we just do this. It just goes to ground. Done. Okay, so big light color. Look at typically the brightness. Calculate our light ground and plus 50 state sign, annotate a sign footprint ready for PCB. Okay, so that will be like that. That will be then everything that is for these. Wait a second. The cost. So how do I know what color? how do I know what property this is and what symbols they show? LED reference light emitting diode. Does it come in the library here? LED. Oh, there you go. Already placed. Device. Blue, green, red. Oh, that's like an RGB one. Oh, okay. Light emitting diode, like a LED. Okay, so I guess that's just like a LED, like just no color, just like the regular one. Okay, that's good. That's good. So if it's the regular one, um, the regular one, it's the regular LED. No color. R and how do I set up? Is it a property? Yes. Guess I click here. I click E for edit, and then I have here I have a value. Resistor. Angle, not mirror, unit, whatever. Don't see a value here. So what are we gonna do? Our symbol, yeah. That's all. Place the resistor symbol R or pick from device wire 15 volts resistor LED and down. Double click on the resistor symbol in the properties window. Look for the value field. Yeah, there's a value field. Usually there's already an R or a blank in. Oh, okay, cool. K2. I can do like that. 1K2, just like these. Right. That's it. No special property beyond these. That's odd. Use the ground power symbol. Um. I'll just use the ground power on these. So we're gonna use. So we're gonna delete one. Ugh. So we're gonna delete this one. This one is gonna hit it like. Then essentially we will connect these. All right. Our beautiful circuit. If your LED turns out not red, whatever it is. So now, so what's next? What's next? Okay, so we have sketch a simple diagram for an LED. So how is the resistor connected relative to the node in your sketch? The resistor is connected to the anode. And that's I already don't know if that is correct, which is the anode. Which is what side of an LED symbol is the symbol looks like there's a triangle pointing to a vertical line. Anode, broad, flat side. I mean, you don't. It's really all right. So we've got the concern of physical layout on a board might differ from the schematic. Yeah, that's kind of the question, right? I mean, now the question is like, what do I do now? So that's a schematic, beautiful. Okay, so and now what? Switch to PCB editor. So can I just so what do we have here? So we have these. We're done with these. We are done with. So we're now construct physical layout of board might differ. Yeah, that's kind of like the next. Listen, I mean, let's look at these, right? I guess we just switch. I guess we just do this mode. Ooh, where did the stuff go? Scripting console. Ah, key. Footprint chooser. Button, battery. What are all these buttons? Okay, so I'm back here. If I switch the schematic, the schema disappears. If I switch the PCB, if I switch to the PCB editor, so I got my schema done. When I switch the PCB editor, it seems blank, and I just turn one to another. So it is no automatic transformation convert schematic directly into public PC layout in one click. Is manual step you trigger, okay, but it's a straightforward one. Just so that's blank by default. Just an export. Here's why it's blank. When your project with the KeyCap project manager window, open the schematic edit. Open the file explorer. The schematic is ready. Run electrical. Oh, okay. So let's run the electrical rules check. Inspect electrical rules check. The ladybug icon. Yeah, ladybug icon here. Inspect electrical rules check. Schematic is not fully annotated. Why is not connected to anything? Okay, cool. Okay, it's good. It's good. Okay, so this wire's not. Okay, that's interesting. Okay, so that's like the equivalent to like a static analysis, right? So that's the equivalent to a static analysis, I guess, where they essentially telling you what is wrong. You guys tell me if it's good. Like, I want you to see have the monitoring. So all right. I just how the physical layout. Okay, we can't even consider how the physical layout looks like if we're not even how am you so how am I placing that? We're not even there yet. Okay, so we need to actually electrical rule checker. Wires not connected to. Okay, input power pin not driven by any output power. Input power pin not driven by any output power. What does it mean? Do I just need? I think this might just be the wrong. I need to. I need to. Yeah, okay, but that's the power. Then what? Driver monitor. Global ground, no. Power flag. So what is the... Okay, yeah, we did these. I remember 15V. Sure. That's what we did. And then... Okay, fine. Now it says electrical. Let's open. Checker. Copy it. Find power pin, power input symbol. Input power pin not driven by any output power. So I get when running the rule checker, I get power pin not driven by any output power pin. What's an output power pin? Not a real wire mistake. Yeah, being about who supplies power. So press every pin on every symbol with the type input, output, passive, power input. PRC has a rule that says any net with a power input must be driven by at least one power. These are things like the output of a voltage regulator, battery positive, a special flag that says power comp. Okay, so can I just like so I actually have to plug something. Oh, so what? Really? So I actually have to. So that's essentially ground, and that's basically saying, okay, the power comes from somewhere. Okay, let's see if we pass. Not connected. Input power pin, not driven by any output power. No, then that's not it. That's output power. What is it now? The out pin or voltage reg. Power output. And I'm gonna wrap it up. Power output converter. LM37. Oh, it's just like a battery or something. Positive terminal of battery symbol that has to be that one. Okay, I can do the. I just read the power flag because I said the power flag before. I don't really. So it just can be like these, and let's see if it passes. And I'm gonna wrap it up here for today. Why are these things not connected? Things really connected. What is? Oh, what is wrong? Do these things really connect? No idea. How does this? Okay, then maybe just these. Can I just do this? Can I just do this? Electrical. I think I can just do this, right? I assume the 15 volts thing was already the fake one. Can I just do this? And I'm gonna wrap it up here. Yes. Okay, cool. Pin connected. Passive line. Pin not connected. Okay, wait. Pin not connected into passive. Wire's not connected to it. But it is, right? No, it's not. Okay. How do I connect the wire? How do I connect wires? Tells me these are not connected. Um, okay, now. No, but it says it's not connected, right? Anyway, I'm think I'm gonna wrap it up here, guys. It's not connected. Okay, it just I'll figure it out. It's just a thing. Maybe it's something where you need to do this, then double click. Could be. No. Oh, I think I need to do it like this. They need to kind of meet in the middle. It gets disconnected. Why? That's odd. Okay, that's just a figured it out. I'll figure it out. I'm gonna pause the session and you guys later. Okay. Okay. Cool. So we now have the Oh, and I see what happened actually. I just restarted this. Now let's see if I actually mention project. I have two. Oh right. Okay, I get it. Starting. That's actually a little like if I start from the actually. That's fine. All good. That is actually. All right, guys. Perfect. Then yes, I'm gonna wrap it up here. We've done a bit of these. Now we are almost ready. So I think it's just a matter of figuring out how to connect correctly, and then we'll just whatever move it to the line and have something. Then after we've done this one, we'll do something cooler. Maybe we'll do like a more like an interactive board or something like this. We'll figure it out. I just need to figure out how things work. And anyway, you guys.